Hello everyone, you're welcome to this video. I remain your tutor, Mr. Life Changer. In this video, I'm continuing question and answers, past questions, waec past questions on chemistry. Okay, so this one says a shortened form of the periodic table is shown below. Use it to answer questions A and B. This is the shortened form. This is the first 20 elements. That's how it is. Right, okay. The shortened form of the periodic table. Which of the elements is represented as A to E in the table? And above is I transition metals, II alkaline earth metals, and so on and so forth. Okay, I think that's quite easy. Now, if you look at this is group 1, group 2. This one where nothing is mentioned, where there is a gap here, actually represents transition metals. Okay, represent transition metals. Then we have group 3, group 4, group 5, group 6, group 7, and group O. Okay, and because that is exactly how the periodic table is written. You have the S block element here, you have the D block element here, and you have the P block element somewhere here, and you have the F block element somewhere here. Okay, so the first one says which one is a transition metal? Of course, E is the transition metal here, is a D block element. So then the other one says alkaline earth metals. Alkaline earth metals are group 2 elements. So this is group 1, group 2, so that is D. Okay, but alkaline metals, group 1 are alkaline metals, group 2 alkaline earth metals. Group 3 says the least reactive. The one that is least reactive, that is not reactive at all, is A. That's group 8 elements. They are rare gases, they are not reactive. Then the other one, most electronegative element, of course, the one close to A, which is this, B. Okay, halogens are the most electronegative element, which is fluorine. Fluorine, amongst all of them, all the elements, the most electronegative is fluorine. And this is the position of fluorine. So I'm going to put here F, fluorine. Okay, so, sorry, not F. The symbol there is B. Okay, now, the next question says, what type of bond would exist in a compound formed when element D reacts with oxygen? Let's see, element D. Element D is a group 2 element, and group 2 element is a metal. Oxygen is a non-metal. The type of bond would definitely be an ionic bond. You can call it an ionic bond or an electrovalent bond. Okay? So the next one says write the formula of the compound formed. Okay, so D is a group 2 element, so you're going to, that means he has a valency of +2 or oxidation number of +2. Oxygen has an oxidation number of -2. So since they have the same number, it means that the element should be DO, just like this. That's how the compound will be written, DO. I hope that makes sense. Okay, so let's see another here. This one says, what is a transition element? A transition element is an element that has partially filled d orbitals. Any element that has partially filled d orbitals are transition elements. Okay, so they are elements in the D block elements, and they have different properties. You can also talk about the properties of transition elements. For example, one of them is that they are colored. The transition elements are colored. Okay, another property is that most of them are attracted, they can be influenced by a magnet. Okay, most of them they are paramagnetic, they can be attracted to a magnet. Another property of a transition metal is that they have multiple oxidation states. That's one way to know them. So you can see something like manganese can be +2, can be +3, can be +4, can be +7, and so on and so forth. So that's another property of transition elements. So this is how you define this. I hope that makes sense. Now the B part says consider the electron configuration of the following. We have this: A is this, B is this, C is this, and D is this. State the elements which form doubly charged cation. Doubly charged cation means something that looks like this, plus, and it must be doubly charged. That means like 2+. So that means that's the one that has a valence electron of 2, which is this. Okay, so the answer is B. Now I want to put here that if you are asked to find which of them is doubly charged anion, anion is negative ion, the answer would have been A, because 268, remember cation is formed by losing electrons, but anion is formed by gaining electrons. So 286 means that this can gain 2 electrons to become stable, to become octet in configuration. But why this one to become octet, it has to give away 2 electrons. So the answer to this is B. Now the next one says which of them will form soluble triisocarbonate. Well, I'll watch my videos on types of reactions. You are going to learn a lot there. But I like to say this here, that all triisocarbonates are not soluble. All of them are not soluble except for sodium carbonate, potassium carbonate, and ammonium carbonate. If not, all of them are soluble. And sodium carbonate, this C here, is sodium 281, 2 plus 8, 10, 10 plus 1, 11 is sodium, so can form a soluble triiosocarbonate. You see, so you just have to know these things. Now the C part says explain briefly why there is a general increase in the first ionization energy of elements across the period in the periodic table. I already explained this in a previous video on this, but I will just mention that here, that the reason for increase in the first ionization energy across the period is because nuclear charge increases across the period. As you go across the period, nuclear charge increases, which is the attraction. Nuclear charge is the attraction of electrons towards the nucleus, the inward pull of electrons towards the nucleus, and the more that attraction, the more difficult it is to remove an electron from it. So that's the reason why as you go across the period, ionization energy increases, because first ionization energy is the energy required to remove first electron, the first valence electron from an atom. I want you to always know that. Okay, thank you very much. See you in my next video.